All right, let's talk about the cosine of 4 pi over 3. The cosine of 4 pi over 3. What quadrant is 4 pi over 3? Third. So for sure it's cosine, it's got to be negative. Since it's something pi over 3, the cosine is going to be, in this case, a negative 1/2, is what I heard. Okay, now the next one, negative 210 degrees. If we think about its coterminal angle, its positive coterminal angle, negative 210 is the same as what? Okay, so this could also be thought of as the tangent of 150 degrees, which we know is negative because we're in the second quadrant. Okay, it's a 30-degree tangent. So some of us have done this enough to remember that we have negative radical 3 over 3. Some of us don't have that stuck in our brain, and that's okay. But we know we need to take y divided by x, and the 2's cancel, and we're left with 1 over radical 3, which has to reduce negative radical 3 over 3. Okay. Huh? Because it's 1 divided by radical 3, then we have to rationalize. All right, now 11 pi over 4. I feel like that's more than one rotation, right? What's its coterminal angle? If we subtract 2 pi, it's the same as what? 3 pi over 4? Awesome. Okay, so 3 pi over 4 is in the second quadrant. Is cosecant positive or negative? Is the sign positive or negative in the second quadrant? Positive, and we're taking the reciprocal of our sign, okay, which reduces down to radical 2. Okay, think to yourself, how did that go? If these aren't coming to memory very quick, we need to continue to practice. Luckily, today, what we're doing in section 4.4 is a lot of the same thing, but we're going to go backwards. Okay. So section 4, we're going to split up into 2 days. Today, we're going to focus on some things with the unit circle. Okay. Tomorrow, we're going to look at evaluating trig functions, not with special angles. Okay. So section 4 is all about trigonometric functions of any angle. Basically, we can go to any quadrant 1, 2, 3, or 4, and we can evaluate sine, cosine, tangent, cosecant, secant, and cotangent, no matter what the angle is. So today, we're going to start off and just focus on our special angles, 30, 60, 90, 45, and their reference angles. Okay, so let's just remind ourselves that in the coordinate plane, all students take calculus. All of our trig functions are positive in the first quadrant. Of the 3, sine is the only positive in the second, tangent in the third, cosine in the fourth. Okay, so what I'm going to present you with today are problems like this. For each of the following, find the solutions to the equations where theta is between 0 and 360 degrees and 0 and 2 pi radians. So I want the answers given both degrees and radians. So go ahead and write down the cosine of theta equals 1/2. so hold on. Okay. So this right here is me asking you, hey, in one rotation of the unit circle, where is the cosine equal to 1/2? So let's first focus on our degree measurements. Okay. Let's also think about where the cosine is positive. The cosine is positive in two places, quadrant 1 and quadrant 4. I know, 4. Yeah. My son used to do this trick. What do you do? That's really what I was. That's what I was doing. Okay, cosine. We need to think of the x coordinate in the first quadrant. What degree measurement has an x coordinate of 1/2? Grayson is very unsure, but he said 60 degrees. Yes? He whispered, so that's why I was not sure what it's talking about. Okay, so now let's go to the fourth quadrant. What angle with a 60-degree reference angle in the fourth quadrant? 300 degrees. Then you're also going to give them to me in radians. Our first quadrant angle is pi over 3. Our fourth quadrant angle is 5 pi over 3. And we are done. That's all we're doing today. Problems like this. All right, that one was nice, right? And the cosine is 1/2. So let's get a little bit more crazy here. The cosecant of theta equals radical 2. I want you to think of right now, cosecant's the reciprocal, just in your head, the cosecant's the reciprocal of which trig function? Owen, which trig function is cosecant the reciprocal of?
Sin.
What? How about sine? Okay, don't call us. There's no sin in that. Sine. Cosecant the reciprocal of sine. And we have a positive radical 2. So I want you to think of where the sine ratios are positive. Which quadrant?
1, 2.
Yes, 1 and 2. Okay, Nate, you see that radical 2 up there. What angle is the number radical 2 typically associated?
45.
Okay, 45 degree angle, right? If we take the reciprocal of 2 radical 2 over 2, the reciprocal 2 over radical 2 simplifies to radical 2. Okay, so we're talking about our 45 degree angles. So we said quadrants 1 and 2, so 45 degrees and 135 degrees. And so our radians would be pi over 4 and 3 pi over 4. Okay. This is going to help your unit circle memory because now we're thinking backwards. We've gone forwards, now we're going backwards. So it's really solidifying that knowledge that's like on the verge of being memorized. Okay. All right, the tangent of theta is undefined. Are you okay?
No.
I want you to have a discussion at your pod about how you think we should approach this problem. And if you think you have any ideas for what the answers would be. Ready, set, go. Question. Okay. Jalen, what did your pod discuss? At 90 degrees and 270 degrees, the x coordinate is 0. So when we take y divided by x, we are undefined. So pi over 2 and 3 pi over 2 would be the radian measurements. Do we agree with Jalen's group? The sun is shining, it's warm outside. Get through the day and we can go enjoy the afternoon, okay? You all look like you haven't had a full week of school in like a month, right? All right, the sine of theta equals 0. Okay, so we need to think about where the y coordinate is 0. Isaac, do you know where that happens? Good. Now, because the instructions did ask for our angle to be between 0 and 360, but do you notice the equality with those inequalities? If you write 360 degrees, I'm not going to be upset, but technically they don't want 360 because it's the same as 0 degrees. Okay. Like I said, if you write it, I'm not going to count you off. Okay. But those will be the same instructions in the book. So just don't be alarmed when that happens. Okay. So also 0 and pi. I like this one. Oh, sorry. Oh, the cotangent. I tell you what, tangent and cotangent take a while to really like get used to in terms of our 30 and 60 degree coordinates, right? The tangent of 45 degrees is 1, all right? So that's nice. But when we have the radical 3/2 and the 1/2, we have to do some thinking, okay? So first I want us to figure out what quadrants we're dealing with. The cotangent reciprocal of tangent is positive in quadrants 1 and what's the other one? 3. Okay. Now, we need to figure out an x over y ratio that's going to equal radical 3. Okay. Maybe some of you know off the top of your head what this is going to be. Maybe some of you don't. Okay. So let's just trial and error. We have two different options. We can take 1/2 divided by radical 3/2, or we can take radical 3/2 divided by 1/2. Okay. Well, when we take 1/2 divided by radical 3/2, we get 1 over radical 3. Is that what we want? No. When we take radical 3/2 divided by 1/2, when those twos cancel, is that what we want? Okay. So which x over y would be radical 3/2 over 1/2? Which x is radical 3/2? Which angle? 30 degrees. In quadrant 3, that would be 210 degrees. We have pi over 6, and in quadrant 2, 7 pi over 6. Okay. This is what we're going to do. I am going to, actually, I'm going to partner you up. We have a lot of like gaps in the room, so I'm going to partner you up. And what's going to happen once I partner you up, you are going to take turns asking each other questions. My preference would be, if you're asking the question, you're holding your unit circle. If you're answering the question, I want you to try not to use your unit circle. Okay. So if my partner is Patton, I have my unit circle and I'm just making something up. So I see my unit circle. How about negative radical 2/2? Let's see. When is the cosine of theta equal to negative radical 2/2? And then he answers that question. Okay. So the one asking the question is going to also have to know the answers. Okay, but I want you to do a variety of sine, cosine, tangent, and even the reciprocal functions, okay, and get some different angles, okay? Maybe you can try to stump your partner, I don't know. So everyone, kind of close your notebook for now, but grab your unit circle, and I want you to line up up here by just the birthday. Like not the month, not the year, the day. So if you were born on the 1st of a month, start at the door all the way 31st at the end. Ready, set, go.